Okay, this lesson is going to cover 5.5 and it's really going to cover all of it. Okay, some basic properties. We're going to deal with multiplying and dividing rational functions. Okay, so that's basically multiplying and dividing fractions. Okay, so our first example here, we're going to do, it is 3x squared minus 6, 3x squared minus 6x over x squared minus 6x plus 9 times x squared minus x minus 6 and x squared minus 4. Okay, so we factor. Everything we do, we're going to deal around factoring. So we're looking here. That's got a GCF. The GCF is 3x, so I'll pull the 3x out. I'm left with an x minus 2. Looking here. That's a perfect square trinomial, so that's x minus 3, x minus 3. Looking here. That I want the factors of negative 6 that add to negative 1, so it's negative 3 and 2. X minus 3, x plus 2. And then looking here, x squared minus 4. That's a difference of squares, so that's x plus 2, x minus 2. Things start to cancel for us. It's nice. X minus 2 shows up twice on the top and the bottom. X minus 3 shows up on the top and the bottom. X plus 2 shows up on the top and the bottom. So we end up with 3x over x minus 3. That's that one. Okay, a property we need to cover when we divide by a fraction, what do? We multiply by the reciprocal. Okay, so that's if I have x over y times, or divided by a over b, I get x over y times b over a. That's how that works. So look at a couple examples involving that property. Example 2, 14 over 15 divided by 7 over 5. Okay, so we take that and we rework that as 14 over 15 times 5 over 7. And stuff will cancel for us. 14, 7, that's a 1 and a 2. 15, 5, that's a 1 and a 3. So I get 2 times 1 over 3 times 1, so I get 2/3. Looking at another one, I have 6xy over a squared times 3y over a cubed x. Okay, so not times, divided by. So what we do is we apply flip the fraction because we're dividing by a fraction, so we get a cubed x over 3y. Okay, so we've talked about these. There's certain ways to do it. I'm going to evaluate the top first. 6 times 1 is 6. X times x is x squared. A cubed times 1 is a cubed, and y stays by itself. On the bottom, I get a 3, a squared y. Stuff starts to cancel. Y's cancel. One on top, one on bottom. Okay, the 6 and the 3 reduce to a 1 and a 2. And then the a cubed and the a squared, the a stays on top with an exponent of 1, 3 minus 2. So we put it all together, and on top I have a 2x squared a. On the bottom I have a 1. Normally we'll write that as 2ax squared. Okay, so that's basic ones in regards to your division. All right, so let's see if we have a little more straightforward ones for you. All right, so let's look at another example with these. Another example would be something of the form here we go. Example 4. 1 minus x squared over 3x plus 4 divided by x squared plus x minus 2 over 9x squared plus 24x plus 16. Okay, factor, factor, factor. That's what we're doing. That's a difference of squares. So it's 1 plus x, 1 minus x. 3x plus 4 doesn't change. Okay, this flips. 9x squared plus 24x plus 16, x squared plus x minus 2. Now, moving forward, we got to factor this. That looks like a perfect square trinomial. It in fact is a perfect square trinomial. It is 3x plus 4 times 3x plus 4, or 3x squared in the bottom. We want factors of negative 2 that add to positive 1. Negative 2 to 1, that's 2 minus 1. So x plus 2, x minus 1. I'm going to flip that around to x plus 1. Okay, so this thing's interesting. Okay, 1 minus x, I've got something that kind of looks like that with x minus 1. What I can do is I can pull out a negative 1 and make that x minus 1. I get a 3x plus 4. And now I can just cancel 3x plus 4, 3x plus 4, x minus 1, x minus 1, and I put it back together. Back together means it's a negative times x plus 1 times 3x plus 4 over x plus 2. That's that. And one last type to match your problems that you have. We have one like this where you have, it's example 5, 6p squared q over r divided by 3pq squared over r divided by pr over 2q squared. Okay, so when this happens, we just go 6p squared q over r. We just change all of this to multiplication, 2q squared over pr. We do that, put everything together on the top. Okay, everything together on the top means I have 6 times 2, which is 12. P squared by itself, q and q squared gives me q cubed, and then an r gives me r. On the bottom I have an r times an r, which gives me an r squared. A 3 goes there, nothing else. I have a p and a p, which gives me p squared, and then I have a q squared. No other q's. Now we'll look at each piece. 12 and 3 reduces to 1 and 4. P squared, 1 and 1. Q squared, q cubed gives me a q on top. R and r squared gives me an r on bottom. So I end up with a 4q on top and an r on bottom. And that's your final answer.